Imagine this. It's just another morning. Your alarm clock rings, pulling you from sleep. You stretch, yawn, and glance out the window, only to notice something odd. The world outside is still pitch black. No golden rays spilling over the horizon, no chirping birds, no light. Just darkness. At first, you dismiss it. Maybe it's just a storm, you think. But as the minutes stretch into hours, a sinking realization grips you. The sun isn't late. It's missing. The streets descend into chaos. Traffic lights blink uselessly in the darkness, leaving cars stranded in confusion. Planes are forced to land wherever they can, unable to navigate without daylight. Schools, offices, and factories grind to a halt as uncertainty grows. Panic spreads like wildfire. Some think it's a solar eclipse. Others fear it's something much worse. Crowds gather around televisions and smartphones, hungry for news, but the broadcasts only fuel the fear. Scientists are scrambling for answers, but there's no explanation. What could cause the sun, our constant, life-giving star, to vanish without a trace? How long would it take for humanity to understand the unthinkable? Hours? Days? The sun isn't just gone. It's not coming back. A chill runs through the air as temperatures begin to drop. People light candles, huddle indoors, and stare at the black sky in disbelief. Is this the beginning of the end? Could you survive in a world where daylight ceases to exist? What would you do if your reality, your very sense of time and normalcy, was shattered in an instant? Imagine the fear, the uncertainty, and the desperate search for answers. But this is only the beginning. What happens next, when the cold sets in and our planet begins to transform, is where the real story unfolds. For 8 minutes, the world would carry on as if nothing had happened, blissfully unaware of the catastrophe unfolding in the heavens. To understand why, we need to delve into the fascinating science of light. You see, sunlight takes about 8 minutes and 20 seconds to travel the 93 million miles from the sun to Earth. Light moves at an incredible speed, 186,000 miles per second, but even at that pace, the vastness of space imposes this slight delay. This means that if the sun were to vanish at this very moment, we wouldn't notice it right away. Think about it. Right now, as you sip your coffee or go about your day, the sunlight streaming through your window is 8 minutes old. If the sun disappeared, the skies would remain blue, the warmth on your skin unchanged. For just a little longer, the Earth would continue its orbit, spinning in the dark abyss, still tethered to the gravitational pull of a star that no longer exists. It's as though the sun leaves behind a final echo, a faint delay before the full weight of its absence hits us. But then, reality would strike. The light would fade, plunging the planet into an unrelenting night. The gravitational connection that holds Earth in its cosmic dance would snap, sending our planet hurtling into the void. In those 8 minutes, we would experience one last fragile moment of normalcy before the universe revealed just how dependent we are on this fiery giant. Why? Don't we feel the impact instantly? The answer lies in the speed of light and gravity itself. Both travel at the same cosmic pace, binding us to a star that, in many ways, governs the rhythm of life on Earth. This brief delay is a stark reminder of how interconnected we are to the sun, and how even the tiniest interruptions in this fragile balance can spell catastrophe. Imagine the irony. For 8 minutes, we would live in blissful ignorance, carrying on as though nothing had changed. But with each passing second, the sun's final rays would race toward Earth, bringing with them the shadow of a dark and uncertain future. Imagine a world plunged into darkness for 24 hours. At first, the only noticeable difference is the eerie absence of daylight. But without the sun's warmth, the temperature starts to drop, and fast. By the end of the first day, global temperatures would plummet by several degrees. Within a week, they could fall below 100 degrees Celsius, 73 degrees, in many regions, far too cold for life, as we know it, to survive. The Earth's heat budget is a delicate balance, driven by the constant energy we receive from the sun. Once that energy is gone, the planet has no choice but to radiate away its stored heat. The oceans, vast reservoirs of thermal energy, would begin to cool rapidly. At first, a thin layer of ice would form on the surface, but it wouldn't stop there. Without the sun to recharge their warmth, the oceans would eventually freeze solid, trapping marine life beneath a thick, unyielding sheet of ice. The atmosphere wouldn't fare any better. As temperatures plummet, water vapor in the air would freeze, falling as snow and reducing humidity to near zero levels. Carbon dioxide and nitrogen, the primary components of our breathable air, could eventually liquefy in the frigid cold. Imagine stepping outside into a world where even the air itself feels like it's been stolen away, leaving nothing but an inhospitable void. Could humanity survive this relentless descent into an icy oblivion? In theory, yes, for a time. Our technology would give us a fighting chance. Underground bunkers, geothermal energy, and nuclear power plants could keep small pockets of humanity alive. But even these solutions would be temporary. The longer Earth remains without the sun, the harsher the conditions become. Crops would fail almost immediately without sunlight, and food supplies would dwindle. Infrastructure would buckle under. The weight of snow and ice and energy grids would eventually collapse. Now, picture the oceans freezing over completely. How long would it take before Earth itself became an ice cube, a frozen husk drifting through the void? This is the stark reality of a world without the sun, an unstoppable march toward extinction, with every day colder and darker than the last. Without the sun, life on Earth would grind to a halt almost instantly. The first casualty? Plants. Photosynthesis. The process that powers almost all life on Earth, would stop within minutes of the sun's disappearance. Deprived of sunlight, plants would quickly begin to wither and die. Some might cling to life for a few days, relying on stored energy, but their end is inevitable. With plants gone, the very foundation of our ecosystems would crumble. The impact on animals would be just as devastating. Herbivores, which rely on plants for food, would face starvation within weeks. As their numbers dwindle, predators would follow suit. Entire food chains would collapse, leaving only the most resilient species struggling to survive. Insects, fungi, and deep-sea creatures adapted to extreme environments might endure for a time, feeding on decaying matter or relying on geothermal heat. But even these survivors would face an uphill battle in a world without sunlight. Humanity, too, would find itself in a dire race against time. Modern agriculture, dependent on sunlight, would cease to function almost immediately. Stored food supplies might sustain us for a few months, perhaps a year at most. But as resources dwindle and temperatures drop, the struggle for survival would become increasingly desperate. Would humanity, with all its ingenuity, be the last survivor or the first to fall? Could any species adapt to this new reality of eternal darkness? Some organisms, like deep-sea creatures living near hydrothermal vents, are already accustomed to a life without sunlight. These ecosystems thrive on chemosynthesis, a process driven by chemical energy rather than solar energy. But even they would face challenges as the oceans freeze over and Earth's energy sources grow scarcer. It's a chilling thought. A planet teeming with life, reduced to a barren wasteland in mere months. Plants, animals, ecosystems, all gone. Humanity, with its fragile grasp on survival, forced to grapple with the grim reality of a world where life, as we know it, has stopped. Without the sun, the entire solar system would descend into chaos. The sun's immense gravitational pull, which holds the planets in their orbits, would vanish along with its light. For the first 8 minutes after its disappearance, nothing would seem amiss. But as gravity, like light, propagates at the speed of causality, the moment the sun's influence ceases to reach Earth, everything changes. Earth, no longer anchored by the sun's gravity, would veer off its orbital path. Freed from its elliptical journey, our planet would become a rogue spaceship, hurtling into the dark void of interstellar space. Without the sun's guiding force, there's no telling where Earth might drift or what it might encounter along the way. Imagine a world no longer bound to a home, set adrift in a universe that offers no shelter. The other planets in our solar system would face a similar fate. Mercury and Venus, closest to the Sun, might escape into nearby trajectories, but their orbits would no longer align. Gas giants like Jupiter and Saturn, massive enough to exert significant gravitational forces of their own, might draw smaller objects, moons, asteroids, even neighboring planets, into their chaotic orbits. Collisions could occur, turning the solar system into a cosmic pinball machine of drifting debris. The asteroid belt, once held in place by the delicate balance between Jupiter and the Sun, would scatter into disarray. Countless rocks and icy fragments, no longer tethered to their stable paths, could pose a threat to planets and moons in their newfound wanderings. Earth, as it drifts, might encounter this debris field with catastrophic consequences. Could anything replace the sun's gravitational pull? Theoretically, if a massive enough object, like a passing star or a black hole, entered our solar system, it could assume the role of gravitational anchor. But such an encounter would bring its own perils, potentially tearing planets apart through tidal forces or ejecting them from the system entirely. In this grim scenario, the once harmonious solar system becomes a collection of lost worlds, aimlessly drifting in the dark. Earth, our once familiar home, becomes a lonely spaceship, propelled by inertia into the infinite abyss. Without the sun's gravity, we lose more than light. We lose our cosmic order, our stability, and perhaps our sense of belonging in the universe. Could humanity rise from the ashes of a sunless Earth? Or would the darkness swallow us whole? In the face of such a cosmic catastrophe, survival would depend on our ability to innovate and adapt like never before. While the odds would be stacked against us, history has shown that humanity possesses remarkable resilience. Even in the most extreme circumstances, underground bunkers might become our first line of defense. Shielded from the freezing temperatures above, these shelters could house small populations sustained by geothermal energy, stockpiled food, and water reserves. Advanced hydroponic systems could grow food under artificial light powered by nuclear reactors. The heat from these reactors could also provide warmth, allowing life to continue, albeit in confined, controlled environments. But how long could such systems endure before supplies dwindled and machinery failed? Artificial light on a global scale presents another possibility. Massive nuclear-powered grids could illuminate parts of the surface, providing energy to sustain crops and ecosystems. However, building such infrastructure in time would require unparalleled coordination among nations. a feat that seems daunting even in today's relatively stable world. Some might even look to the stars for salvation. Could humanity evacuate Earth and colonize other planets? Current technology falls far short of such a monumental task, but adversity has always been a catalyst for innovation. In the 20th century, humanity achieved the seemingly impossible by landing on the moon. Could the loss of the sun push us to develop faster-than-light travel or sustainable space habitats? If so, this dark chapter might give birth to a new era of exploration and survival beyond Earth. Our species has faced near extinction before, surviving ice ages, natural disasters, and even nuclear threats. In every case, creativity and cooperation have been our greatest tools. But would they be enough to overcome the challenges of a world without the sun? Could we come together to build a future from the ashes, or would fear and division seal our fate? As we ponder these questions, one thing becomes clear. The sun is not just a distant star. It's the foundation of life, order, and hope. Without it, we would have to redefine what it means to be human, turning our ingenuity and resilience into the last light shining against the darkness. If the sun were to vanish, could we ever bring it back? Or would humanity have to forge its own path through the darkness? This question transcends science fiction and ventures into the realm of speculative science, where the impossible becomes the spark of innovation. While the idea of reviving the sun may seem far-fetched, imagining how we might light our own future forces us to confront our greatest fears and our boundless potential. One possibility is the creation of an artificial sun. Scientists are already experimenting with nuclear fusion, the very process that powers the sun. A fusion reactor capable of generating the energy output of a star could theoretically sustain life on Earth. Imagine massive stations orbiting the planet, beaming light and heat to replace the sun's life-giving rays. Though this technology is in its infancy, it represents a glimmer of hope, a way to recreate the light we once took for granted. Another theory ventures into the extremes of astrophysics, harnessing the energy of a black hole. Black holes, despite their fearsome reputation, emit immense amounts of energy in the form of Hawking radiation and accretion disk jets. If humanity could find a way to capture and convert this energy, a black hole could become a new source of light and warmth. Of course, the risks of such an endeavor are almost as great as the rewards. Some dream even bigger, leaving Earth behind to find a new home around another star. Advances in space travel might one day allow us to journey to nearby star systems like Alpha Centauri. This would require an unprecedented level of cooperation and ingenuity, transforming humanity into an interstellar species. But could such a plan succeed before Earth becomes uninhabitable? And would we be able to recreate the delicate ecosystems we'd leave behind? Beyond the science, the disappearance of the sun forces us to reflect on our place in the universe. It reminds us how fragile and precious life is, and how deeply interconnected we are with the cosmos. If we can't bring the sun back, we must ask ourselves, could we become the light of our own future? Would this catastrophe inspire us to rise above our divisions and embrace the boundless possibilities of human potential? Perhaps the sun's absence would be a test, not just of survival, but of imagination, unity, and hope. And maybe, just maybe, in the face of cosmic darkness, humanity could learn to shine brighter than ever before.